Good afternoon. Welcome to this Unreal Summit. My name is Sébastien Miglio. I'm Director of Product Management for Unreal Engine 4 at Epic Game, and very happy to be here with you today in Seoul. So in this session, we're going to talk about how manufacturing is changing and how real-time is helping the way products are created. The talk will mostly cover the automotive sector because it's a place where Unreal is being used a lot, but we do have customers also in aerospace, furnitures, and other sectors that are using Unreal for manufacturing almost in a similar way. So what I'm going to say today is going to be applicable for other industry as well. So in this presentation, we're going to start to talk about some of the obvious Unreal Engine benefits that are the reason why basically we enter that market. And then we're going to look a little bit more at the product life cycle on how Unreal can plug itself into the product life cycle development from design to training. And then we're going to talk a little bit about product autonomous vehicle development. And then we will finish by diving into some of the important features for manufacturing at the end of the presentation. So first, let's talk about some of the key features of the engine that made people from the manufacturing sector adopt Unreal Engine. And as I said, these are generic benefits, so they could be applied to, in fact, any industries, but they were very appealing for manufacturing because they really transcend all the phases of the product life cycle. And in fact, in the industry manufacturing sector, basically our licensees started to use Unreal Engine even before we knew about it. So some of them were really pioneer in real-time technologies. So the first reason behind the success of Unreal Engine in manufacturing is rendering. And Unreal Engine has always been known to push the limit in terms of quality and performances. And with Unreal Engine in real time, especially today with ray tracing, since version 4.22, you can really reach visual level of fidelity that traditional offline renderer could do. But on top of that, you're gaining the interactivity aspect. And today we see a lot of OEMs from automotive and aerospace sector that are replacing their legacy rendering technology stack by real-time like Unreal Engine. But it is important to mention that Unreal Engine is not just a faster renderer, because that would be very limiting and that would not bring too much value to the entire product lifecycle process. So one of the other important aspects of Unreal, especially in manufacturing sector, is really the fact that you can experience your project on every platform, especially AR and VR. And in fact, with the release of N-Display, Unreal is even suitable for cave or Powerwall system, which are very big, immersive, projection-based environments. And in the industrial sector, there are really three key areas where Linux shines from a platform perspective. The first one is VR, because VR became mandatory tool in design and engineering. If you want to review or analyze industrial models, it is the most cost-effective way to do it so, because it's much more affordable than cave and projection system. And it allows you to experience your model on your own at your workstation. The second strong important point around platform is AR and mobility, I would say in general, because it has a huge potential, especially in factories. It is used today to replace paper-based technical documentation, and it can assist factory workers in their operation. And with the recent release of HoloLens 2 and its integration into Unreal, it's even more true. We're going to see a lot of HoloLens 2-based projects for manufacturing in the upcoming months. Finally, when you talk about manufacturing, there is a big aspect around simulation and robotics. And with the Linux support, this is mandatory as it is a standard operating system for those type of development. Also, another very important key aspect of Unreal is source code availability. First of all, the source code is in C++, and that's really the standard development language for industrial platform like robotic and simulation. most of real-time operating system that runs into the car, like the embedded hardware, is often running off C++. Also, it allows customization, because in a lot of industrial projects, the core engine as it is does not always meet all the requirements, for example, for real-time OS. So with source code access, you can start to optimize and tune Unreal Engine for those type of requirements. Also, and that's really for the OEM itself, because you have the source code, you own your assets. And that's really a key point. When you use other proprietary systems, once the assets are imported, it is not easy to get them out of the product. With Unreal Engine, you have access to the source code of the assets, and you can read and write your asset the way you want. And this is really a key element of the strategy of the OEM, as they want to be able to dispatch and basically share their asset with their supplier without having the cost of being in a closed environment. And if you look at, for example, airplane development in aerospace, these are programs that last for 10 to 15 years. So who knows what's going to happen with technology in the future. So having source code access is also a way for the OEM to keep the lifetime maintainability of the system alive the way they want. Then we have all the community resources, because when you develop content, it is very time consuming and you don't always have all the expertise inside the OEM to develop such content. So that's why we have the Unreal Engine marketplace. So first of all, it brings a lot of high quality content, and also it includes 3D assets and sometimes even code plugin. And that helps a lot of OEM kickstarting their projects and enhancing the visual quality of the project at very little cost. There are examples like KUKA robotic system on the Unreal marketplace that are very good, for example, if you do factory design. We will show you that in a moment. Then we have Blueprint visual scripting, because not everybody is a game developer and not everybody has the skill and the knowledge to master C++. And when you have engineer, like mechanical engineer, who wants to just develop simple behavior and control logic, visual scripting language allow really people to do that, because it's a much easier language to use and you don't have to learn all the syntax around. So now that we take a look very quickly at what were those universal benefits of the product, let's start to look more into some real-life manufacturing use cases. So today, Unreal Engine is really being used across most of the manufacturing product lifecycle, as we can see. So of course, the creative people are the ones who have been the first to adopt Unreal Engine, especially during the design of the vehicle in the early phases, and also for sales and marketing. I mean, that's pretty much everywhere where you have pretty pixel. Unreal Engine was a natural fit. But our end users have been constantly discovering new ways to accelerate product development with Unreal Engine. And now we see Unreal Engine being used in engineering, and with the product becoming more complex, with the mechatronic system, with the embedded control system, you have to validate a lot of behavior as soon as possible. And especially you want to do that in synthetic environments, because it reduces the need of physical prototype and real-life validation. So this is why we start to see Unreal Engine more and more in system design and validation, especially for autonomous vehicle development. We're going to have a session dedicated to that later. And those principles also apply to factory design, where visualization really helps optimizing the processes. So we are going in the next few slides to look at how design, engineering, sales and marketing are becoming much faster now thanks to Unreal Engine. So industrial design is an obvious choice for Unreal Engine. I mean, designers are gathering a lot of ideas. They have a very short amount of time to iterate, and they need to visualize the concept very quickly. it is very frequent that design team needs to assemble all the parts they've been working with, and they have to visualize them almost on a weekly, if not daily basis. And of course, they want to do that by comparing the different design variations they've been doing and the different ideas the team member are providing. And typically, all the data they're working with are coming from products like Studio Designer from Autodesk or Rhino. So what I would like to show you is a quick example of a solution done by Google Collective. It's called Vector Suite, and it's designed with Unreal Engine, and it was developed originally for McLaren. And basically, what it allows you to do is basically under an HMD, a designer can start to sketch all his idea in VR, in real time, and at the real scale of the product. So basically, it combines 2D sketching and 3D surfacing all together. And because it's in 3D, the CAD data can be imported as references so that the designer can consider all the boundaries and the limitation of the engineering aspect into the design. So this product that is available from Google Collective is a great example of what Unreal Engine can do and what the interactive capabilities can bring all together, especially in VR and in desktop. One of the other benefits of that technology is that it allows you to export wire format that can then be imported into Rhino or Alias Studio Designer. So it's really part of the process, and it really helps optimizing the design processes and the industrial design for the designers. So of course, if you can use it for exterior design, you can use it for interior design because it's pretty similar. But if you are doing interior design, then it's interesting to talk about ergonomics assessment. Because if you are designing a product, it might be interesting to be able to try it even before you manufacture it. I mean, being able to quickly iterate over new ideas without the need of developing and manufacturing a prototype, which is very expensive, is really something that is convenient. So, in this example, we have been working with BMW to create interior design and what are the impact on ergonomics. So with the number of screens that have been added into the car, the number of interacting dashboards in the cockpit, you have to ensure that the driver is not distracted by all of that electronic, and he has to remain available, capable of interfacing with the vehicle commands. And the main issue that you have is that designs tell you how the vehicle would be in a perfect world, but engineering on the other side is looking at what is feasible to manufacture with the amount of time. And when you combine both, that's where you need those mixed reality platform to validate what's really the impact of design on engineering. So in their mixed reality lab, they have combined hardware such as HMD here with a D-Box motion platform. And by doing that, they can really reproduce the experience of the car. And then they use lip motion and sensor that they can interface with the touch display of the car and really operate the car interactive system as if it was in the final product. And using that digital twin, they can really assess the changes of design on the fly. They can reduce the development cost and time while finding the best solution for their customers. If we continue around the use cases that you can apply for manufacturing, then we can talk about how you are manufacturing them. Because if you're designing new products, you're going to have to build them at one point. And of course, that implies the development of factories. And Unreal Engine can really help you on two different use cases here. The first one is on process simulation and planning. And you want to answer the following question. Can I build the products? Can the workers or the robots assemble it? Can I try the worker before the factory is manufactured to improve their productivity? The other important use case you want to talk about is the factory layout design and operation scheduling. Can I optimize the processes of my factory so that it is more efficient? And doing that before even I manufacture and I build the factory. So again, this is an example that we have been working on with BMW, and this is for their new mini factory in the UK. So they have developed a virtual representation of their factory, and they have basically modeled all the assembly processes within the factory to understand, communicate, and optimize before even building the factory. So with this digital factory, it enables the design of better assembly procedure, but it also helps identifying conception issue as all the processes are not anymore only documented on paper, but also in 3D and animated over time. So that enables everyone involved to fly around, understand the representation, and really grasp what they are developing and manufacturing. And because it is all done in real time, the changes that they want to apply can be experimented quickly. They don't have to wait for a big turnaround or discover the issue once the factory is completed. So after the factory, and once the products are manufactured, in parallel, you want to talk about digital marketing. And when we talk about digital marketing, we want to talk about all the imagery that is required for a new product. Because when you manufacture a new product and you want to release it, you have to address all types of communication channels. You have the print channels, online channels, TV channels, and even more these days. So we've shown this morning an example of our real-time automotive advertising platform done with the Miglio and Chevrolet for the new Camaro. It's called the Human Race. But there are other ways that we can improve and implement Unreal into those procedures. So in this example from Audi, basically they have to deal with all the options around the product that are being developed and made available to customer. So the product catalog that contains all the possible options of a vehicle is called the 150% model. And basically that reference model is used as a central point for generating all the imageries for marketing. So Unreal Engine now enables to store all the product variation in a single model, and then the marketing department and the agencies can quickly generate beautiful content on the fly and switch all the possible configuration and environment to address all the customers in every country. Because the way you sell a car, for example, in Korea might be very different than what you would do in North America or in Europe. And the beauty of that platform is that you can automate the generation of the image in the cloud, and then you can control the generation of image and video from a single web portal, so that people who consume the content don't even need to be experts at Unreal Engine. Of course, this is an example that is done with Audi, but a lot of other OEM now are developing these platforms for quickly generating content, and all in real time. And if we talk about marketing, naturally, the next aspect is the car configurator. Because the benefit of storing the 150% model in a real-time engine is that you can deploy configurator directly at the point of sale with the dealership, or you can implement them online into a website. So I would like to show you an example from a customer. This is a point of sale that has been done by Make-A-Vision for Ferrari. And the idea here is that the customer can design his dream new car on an iPad, and he can see instantly a high fidelity result of all the changes on a large TV at the dealership. These days, those virtual showrooms are mandatory because the amount of option you have for each car is basically enormous, and each configuration is almost a unique car. In fact, with a high-end car, most of the time the car does not exist yet. So when people are ordering and configuring it, it is happening even before the car is manufactured. So it is really important for the customer to really feel what his product will be. And these point of sales are just not dream catcher, because they also generate the exact build-to-order product configuration that the factory will receive. So those systems now these days are even connected to the factory so that it's really streamlines the purchasing process. And while some of them, like the one from Ferrari here, it's only available at dealership, there are other brands that have made their configurator directly into their product web page, and they are using one of the new Unreal Engine features called pixel streaming to render the experience in a cloud and stream the content directly into a web browser, just like you would watch a Netflix movie or a video on YouTube. So, as we've seen, Unreal Engine is really changing the way manufacturing is done, and it's really helping optimizing the entire product life cycle. There are, of course, many other use cases that we could talk about. We have seen now Unreal Engine used in mechanical engineering, in CFD simulation. There are even now people integrating Unreal Engine directly inside the dashboard of the car to be part of the entertainment system. So there's a lot of future in Unreal inside the manufacturing sector. But there is one use case that we have not talked about, and that is really of a great interest for Epic Games today. And this is autonomous vehicle simulation. And more specifically today, we're going to look at how Unreal can help the training and the validation of the autonomous pilot agent. The one, basically the brain that drives the car, the autonomous car, and makes all the decisions. So, the main challenges, or one of the main challenges of developing autonomous vehicle is that you have to test it. And in order to test autonomous vehicle, it requires huge infrastructure. And even then, it is not really possible to reproduce all the driving conditions in a deterministic way. You have no control on the weather, and you have no control on a lot of events happening outside. And if you really want to reproduce test cases, it has to be done in a deterministic way so that you can measure the improvement and the performance on a system. And another important aspect is that you want to test the vehicle even before going on the real roads to avoid problem. All of this is very costly, time-consuming, and basically it does not scale up. These are pictures of the Alphabet Waymo test site that is owned by Google. And this is a quote from John Krafcik. John Krafcik is Alphabet Waymo, the Google self-driving company. He's the CEO. And what he's telling us is that for every miles that their cars are driving in real life, they are driving about 1,000 more miles in synthetic world using concurrent agent to reduce learning time and increase the amount of permutation. This is a key factor, because you have to be able to scale a huge amount of concurrent simulation in a cloud, and you have to reproduce the environment around the car in a way that is as close as possible to reality. And the benefits of simulation in synthetic environment is that it enables as well the discovery of new emerging behavior, things that would have been very difficult to reproduce in real life. And now at Google, simulation is now guiding the way the development of autonomous vehicle is done. So in this example, we're going to look at another company. That company is called Zook. It's a company based in San Francisco, and it's a startup that is working on developing a fleet of autonomous taxi. They've been working on that project for several years. It's not a company that is well known, but they are one of the most advanced companies on the market. And they have developed their entire simulation platform onto Unreal Engine. They started by instrumenting cars that they drove into San Francisco streets in order to capture real-life data. These cars have a precision of 3 centimeters. And using the data they collected, they reconstructed a 3D representation of San Francisco that is very close to reality. Then, into that synthetic world, they can add real-life traffic and pedestrian to reproduce the real-life condition of the streets. And the beauty here is that the vehicle that drives is not an animation. It is a real computer inside the car that believes is connected driving in a real life. In fact, the interface that Unreal Engine exports is basically the same as the ones they have in the computer of the car. So basically they can run seamlessly the computer agent in real world or inside the simulation without even knowing it. And there is another reason that that project is very interesting, is that Zook really want to understand the impact of the changes they are doing. So this is why they are using a real city, because once they run the simulation inside Unreal, they can now go into the streets and measure the changes and the performance of the design. And that provides you a very easy way to measure the improvement. As you can see right now in the video, all the sensors of the car are simulated. The LiDAR, the camera, the proximity sensor, everything is simulated as in real life. Another benefit here as well is that because the computer generates the imagery, it is able to tag automatically. So when they are training the agent, because this is the other part of the process, it's not only validation, because this is based on deep learning technique you have to train, they can automatically tell to the computer, this is a road, this is a car, or this is a human. And that helps developing all the proper behavior of the AI agent. So how do you develop such simulation in Unreal Engine for the development of autonomous vehicle? Well, the first aspect that you have to cover is vehicle dynamics. The physics engine that is included in Unreal Engine, PhysX from NVIDIA, is not suitable for creating high-fidelity simulation. So you need to use engineering software that are specialized in vehicle dynamics. There is 2 strong partners that Epic is working with. The first one is Simulink, that is developed by MathWorks. Simulink has released a software called Vehicle Dynamic Block Set. This is a library of pre-assembled vehicle dynamics model for cars and for trucks. The benefit of that solution is that it comes with several scenes that are provided for Unreal Engine, and these scenes are made for testing advanced driver assistance system, ADAS, as well as analyzing vehicle ride and handling condition. And it allows mechanical engineer or simulation engineer to really simulate exactly the behavior of the vehicle with engineering value. Another interesting partner has developed CarSim by mechanical simulation. The difference is that CarSim is using empirical vehicle model, meaning that they have measured vehicle in laboratories and they have generated model of this vehicle for Unreal Engine. And with the CarSim tool, you can also generate simulation and connect Unreal Engine into the simulation to create closed loop systems to validate, for example, driving behaviors. Both of those products can be downloading for the marketplace, but of course, they have license fees that have to be discussed with the providers. Then, once you have your car dynamics, you have to create the terrain and the road networks. And here as well, we have some interesting partners to work with. We have Train Graphics from Germany, S3 from Switzerland, who is one of the leaders in GIS system. S3 provide a tool called City Engine. And the benefit of this software is that they can ingest GIS data from the real world and help the creation of real cities. They use satellite imagery and city data to have the proper elevation, building information, and road networks. The benefit of Triune Graphics and SRI is that they are all integrating with Datasmith so that the import of terrain data into Unreal Engine is very easy. There are also products like Vector Zero that are providing plugins directly into Unreal Engine to develop road networks. Now, in some cases, because of the deep learning algorithm used for autonomous vehicle, it requires a lot of data. And not only real-life data, but also cities and places that don't exist. And creating such a data by hand is very expensive and laborious. And in fact, it doesn't scale. It's nearly impossible. So then, the best way to deal with these challenges is with fully synthetic data that are completely created automatically. So they are service providers like AI Reverie or Parallel Domain that specialize in the creation of very large environments fully automatically. And the benefit as well of those environments and that they are properly tagged so that the agents, as part of the deep learning process, can easily understand and identify what each part of the environment is. Finally, we even have more complex simulation platforms that are fully integrated into Unreal Engine, like Carla. So Carla has been developing since the beginning to support the development, the training, and the validation of autonomous driving system. So here you have all the components integrated together into one solution. Carla, for example, comes with all the urban and vehicle assets. It includes open source code on GitHub, is integrated into Unreal, and provides a sensor model for the vehicle, environmental condition, the ability to simulate rain, the sun, sunshine, or the snow. And it also includes all the logic of the vehicle and the pedestrian to recreate test sets. There are other systems like Vertex that does that, or EarthSim that is done by Microsoft. All these tools are available today in Unreal Engine, and this is why when you combine all these systems, most of the vehicle development are using Unreal Engine for their own projects. So, we've looked at the beginning at all the core features that Unreal provides in general that are very beneficial for enterprise markets. Here, I would like to look at some very specific features that were developed to help manufacturing end users. The first one is Datasmith. Datasmith is our set of plugins for ingesting external data and preparing them for real time. The things that when you are doing manufacturing is you are not dealing with game assets. There is no artist working in 3D Studio Max or Maya to prepare nice, optimized models that are fitting the budget of the game. Here, you are dealing with assets that are designed to be built in factories. So the first problem you are facing with is the fact that most of those CAD data are based in NURBS format. This is what CATIA, Siemens, PTC Creo, or SolidWorks and Rhino are working with. And NURBS data cannot be dealt with in real time. So when you import NURBS data into Unreal Engine, you need to tessellate them to generate the triangle representation. And that's the first benefit of Datasmith, is that it provides full control on the tessellation parameters so that you can get the right surfaces at import. Of course, importing the geometry is important, but manufacturing data includes much more than that. For example, you have the entire product catalog. To give you an example, a car model today is typically made between 7 and 10,000 pieces that we call parts. If you look at an airplane, typically just for the nose of the plane, the front part and the cockpit, you are talking about 50,000 parts. So these are huge amounts of data that you have to ingest. And these data are very well organized with a big hierarchies and a lot of metadata. So that's one of the benefits of Datasmith, is that it can ingest all that data and convert it automatically into Unreal Engine assets so that you can then work with the data the way you want. By the way, it is important to mention that Datasmith also supports formats like NVIDIA MDL or X-Write AXF. These are material formats used by engineer and designer, and they are generally generated from scanners that really capture the proper BRDF of the material. Or they could be coming from libraries that they get from the material vendor, like for example, BASF for car paint. So, import and tessellation is really the first part of the process. What happens after that is that you have a huge amount of data. And that amount of data is not good for real time because you have way too many information that the engine can render. A typical game will maybe deal with 1, 2, or 3,000 draw calls, objects to render on screen. Here we are talking at this point about 10,000, if not more, parts. So you have to use some tools to prepare the CAD data so that they can run in real time. The first data prep tool that we use is called LOD, Level of Detail. It is a well-known technique in computer graphics, and it is being used heavily in games. What LOD does is that basically it allows you to take one single part and to generate variation of the part with different level of fidelities by reducing the amount of triangle. It is a very effective way to improve performances when some objects are not close by or heavily visible on screen. In Unreal Engine, we have added a tool in the static mesh editor that allows to generate automatically all the level of detail for a single static mesh. The second tool that we added inside Datasmith and Unreal Engine is actor merging. That's a very simple technique where you take multiple static meshes and you combine them, you merge them into a single actor so that you reduce the amount of draw call, the amount of objects you have to render on screen. Typically, you are using actor merging when there is no need to manipulate the part independently. So when you know that some parts are going to be always used together and glued together, actor merging is the right strategy. Another interesting tool is the Proxy Generation. This is somehow similar to the actor merge, or what you are doing is taking multiple parts, multiple actors, and you are combining them into a single one. But on top of merging the parts, the proxy tool is also doing a remeshing or retopology operation. So if you have multiple actors with different materials, the remeshing will regenerate a new material that includes all the other one. So not only the proxy geometry reduces the number of draw calls, but it also reduces the number of triangles. And that is very practical when you have some element where the level of complexity can be easily reduced, for example, with an engine, as in this case. And the proxy generation can also be combined with LOD all together if you want to achieve even further optimization. Then another interesting data prep tool is called Diffusion. So as the name says, Diffusion is a tool that allows you to remove certain features, certain properties of the geometry. For example, in this case, we have some different aspects. We have holes here that have been automatically filled, and we have openings that were automatically closed. So the benefits of Diffusion is that it can remove holes, bump, fillet, and chamfer almost automatically. So when you are, for example, doing a product configurator and you want to visualize a nice part, most likely the assembly parts that are hidden under the car are not required. Using Diffusion is a good way to optimize those parts because they're not really adding value to the visual fidelity of the model. Finally, the last data prep tool is called jacketing. And jacketing is a very powerful optimization technique. Basically what it does is it finds in an assembly all the parts that are not visible from the outside. So it allows you to detect everything that is inside the model that you will never see. In this example with an engine, you have a lot of parts inside the engine that you most likely will never see if you are doing some nice imagery. So in that example, we start with 542 meshes total. Half of them are not visible. What the jacketing will do, it will discover automatically those parts and offer you multiple options, either to tag them, to move them into a different layer, or simply to delete them. So, as you can see, there's a lot of options. And when you import a very complex model, it could take a very long time to optimize the model. And if you are working on an OEM, most likely, as the model changes every day, the same operation would need to be repeated. Because in a factory or a manufacturing environment, the processes are very well defined. And if on top of that, you add the fact that you have very short turnaround, sometimes you need to visualize the model the same day or the morning when you come back, you need to iterate as quickly as possible. And this is why we added Python scripting inside Unreal Editor. With Python scripting, you can access almost every function of the editor, and you can generate scripts that you can operate directly inside Unreal Engine or in a command line from servers. And what you can do is basically completely optimize the extraction of the data from the product management system of the CAD software, load the data into Unreal, and automate the data prep process so that there is almost no manual intervention at the end of the day. And because Unreal Engine is capable of reading the metadata from the CAD, it can also generate rules that are smart and apply the right logic onto the right part. So as your model evolves, those rules will be automatically applied and even further streamline the overall process. So we've talked as well previously when we mentioned the car configurator and the marketing imagery about the 150% model. What basically is used to manage the product catalog and all the options. So in Unreal Engine, we added a feature called Variance Manager. So what the Variance Manager allows you to do is to import the 150% model, identify what are all the options. So for example, for a car, you could imagine that each car paint, each color is an option. Each rim, wheels, interior finish, left driving, right driving, etc. are all options. And of course, depending on the countries, only certain options are available. So with the Variant Manager, what you can do is create all those type of variation and the rules to control them. Once this is done, you can start to switch and see the different model directly in the editor. And when you are developing your variant logic for runtime application, when you are creating your configurator game, for example, then you can use the Variance Manager to control all the variation and the option. So this is a very important feature of Unreal Engine for manufacturing, because this is the only way you can control all the possible options of the product. Unreal Engine offers also a couple of additional nice features. First of all, we have the project templates. These are templates that have been developed specifically for enterprise use cases. Their usage is very straightforward. All you have to do is create a new project and select the templates, and then with Datasmith, import your CAD model and press play. Right now, we have two different templates that are fully compatible with desktop, VR, and mobile. So you can do AR, VR, and regular desktop. The first one is a product viewer template that allows you basically to perform review of the model, move pieces, look around, isolate the parts, or make them transparent versus another. The other template is a multi-user template where you can connect with other colleagues and inspect the model all together and start discussing and sharing ideas and performing annotation onto the model directly inside the 3D scene. And that does not require any development from your side. But because the templates are available as blueprint projects, it is very easy then for you to take them and start to enhance and modify them. Finally, when you are in an enterprise environment, you want to get proper support and training. So for that, we have developed an entire product line of different systems. First, we have Unreal Developer Network, or UDN. This is where basically the Unreal Engine developers are available to answer technical questions. We have also a team of technical account managers in almost every country that are Unreal experts for manufacturing and that can help deploy projects at your site. We have an online learning management platform where you can access all the training material, documentation, and tutorial. And then we also have trainers that can go at your company to deliver dedicated training. And of course, we have also our Unreal Academy event. The next one will be early June at Epic Games HQ in North Carolina. So, as we've seen today, Unreal Engine is already used by a lot of manufacturing industry because it is performant, flexible, and support all the open standards and provide source code access. We are still improving the feature, and we have a lot of things that are going to come up soon. There are manufacturing companies all around the world that have different experiences with Unreal Engine in design, marketing, but also in simulation. If you go frequently to Unreal Engine website, we are frequently updating the story and showing more examples. Thanks for your time. It was really a pleasure to be with you today. Thank you.